Okay, welcome back again. At the end of this tutorial session, you are kindly advised to work out on Bansal exercises on page, page 311, and also numerical problems and theoretical problems starting from page 309 up to these problems. So you can check with these answers given in Bansal. So please work out these problems at the end of this tutorial session. So this is just the fluid dynamics problems. So please try. There are many problems related with our example. Now let's proceed to nozzle, force exerted by a nozzle. So if you have a nozzle which is fitted with some pipe, what will be the force exerted by the nozzle? So a nozzle with 20 millimeter diameter is fitted to a pipe of diameter 40 millimeter. So the nozzle is very small size, but you have pipe 40 millimeter. Find the force exerted by the nozzle on the water, which is flowing through the pipe at a rate of 1.2 meter cube per minute. So I hope we will apply Bernoulli's equation, momentum equation, energy equation, and also continuity equation. So let's start. Now, this is just inlet, which is the main pipe with a diameter of 40 millimeter here, then reduced to 20 millimeter at this end. So what will happen? So flow is to this direction, but pressure is opposing to this one. So just you simply apply Bernoulli's equation at section 1 and section 2. So you have pressure head, velocity head, and potential head, Z1. So since it is horizontal, so I think Z1 is equal to Z2. So you can have P2 over rho G, which is atmospheric pressure, which is 0. So we will substitute. So apply continuity equation at section 1 and section 2, since discharge is constant at inlet and exit. So A1 V1 equal to A2 V2 equal to Q. So V1 you can calculate Q over A1, so 0.2 over area 1, which is pi over 4 d square, this 15.92 meter per second. Then finally you can compute again V2 Q over A2, 63.69 meter per second. Then you can find, after substitution in this Bernoulli's equation, you can find P1 over rho G, which is the pressure. P1 over rho G will give you 193.83 meter of water. So to get the pressure is nothing, rho G H. So you have H, then density is given, so you have to multiply by gravity. So you will find 190.1472 kilonewton per meter square. So this is the pressure exerted. Find the force exerted by the nozzle of water. Once you find pressure, then force will be simple. Force exerted by the nozzle on the water is apply momentum equation. Net force in the direction of x is equal to the rate of change of momentum in the direction of x, which means just summation of net force equal to change in momentum, rate of change of momentum, rho q v2 minus v1. So you have F1, P1 times A1 minus P2 times A2, since opposing, plus Fx equal to rho q v2 minus v1. So where P2 is atmospheric pressure, which is 0, and density is 1000. So you simply substitute in this equation. Then finally, you can arrive at Fx. Fx is negative 1472.09 Newton. So this is the answer. Negative sign indicates that the force exerted by the nozzle of water is acting from right to the left. So it is opposing to the flow direction. So as exercise, please do this one. Firefighters, most of the time, they are using nozzle with small diameter so that you can just calm down the fire emergency. So firefighters are holding in a nozzle at the end of a hose while trying to extinguish a fire. So if the nozzle exit diameter is 8 centimeter and the water flow rate is 12 meter cube per minute, determine the average water exit velocity and the horizontal resistance force required by firefighters to hold the nozzle. So answer is given. Please check this one as your exercise. Okay, the last example for this topic, which is for fluid dynamics, is water jet striking a moving cart. So when you have a moving cart, then if you apply a jet striking at the back of this cart, what will happen? So water accelerated by a nozzle to 35 meters per second strikes a vertical back surface of a cart moving horizontally at a constant velocity of 10 meters per second in the flow direction as shown in figure. So the mass flow rate of water from the mass flow rate of water through the stationary nozzle is 30 kilogram per second. After the strike, the water stream splatters off in all directions in the plane of the back surface of the moving cart. So determine the force that needs to be applied by the brakes of the cart to prevent it from accelerating. Just what is the resistance? And if this force were used to generate power instead of wasting on brake, determine the maximum amount of power that could ideally be generated. If the mass of the cart is 400 kilogram and the brakes fail, determine the acceleration of the cart when the water first strikes it. Assume the mass of water that weighs the back surface is negligible. So I think you have jet of water striking with this velocity, 35 meters per second, just strikes to this back face of the cart, and the cart is moving to this direction with velocity 10 meters per second. So what will happen? So I think required quantities are given. Now let us solve. So we take the cart as a control volume. So as a control volume, you can assume then the direction of the flow as a positive direction of x-axis. So relative velocity between the cart and the jet is nothing, the difference between the two velocities. So relative velocity is velocity of the jet minus the velocity of the cart, which is 35 minus 10, 25 meters per second. So this is the velocity, just relative velocity between the cart and the jet. So the mass flow rate of water striking the cart corresponding to water jet velocity of 25 meters per second related to the cart is nothing, just you can have mass flow rate. Velocity, relative velocity divided by velocity of the jet times m jet, which is mass flow rate of the jet. So if you multiply 21.43 kilogram per second. So this is just the relative mass flow rate of water striking the cart, just corresponding to the water jet velocity. So this is just MR 21.43 kilogram per second. Now apply momentum equation for steady flow in x direction. Reduce to this equation. Net force is equal to the change in force out minus in. So change in velocity, which is just this one, you can subtract. Now net force, resultant force in x direction is negative mass flow rate in I direction, VI. So force in the brake is negative of this one. So since the cart, if you make a brake, then it will be in opposite direction to the relative motion. So we note that the brake force acts in opposite direction to the flow, and we should not forget the negative sign for forces and velocities in the negative x direction, since the direction is in the same. The cart is moving to the right, and the jet is also applying to the right, so you have to consider just opposite to this one, you have to make negative. So substituting the given values in the equation, so force of the brake should be negative of mass, just mass flow rate, which is relative mass flow rate times velocity flow rate. So if you substitute in this equation, you will have negative 536 Newton. So this is opposite. Negative sign indicates that the braking force acting in opposite direction to the motion. So the power wasted by the brake is nothing, just power is nothing, work done per unit time. So just W dot means just power per unit time. So force times velocity is I think the power force of the brake times the velocity of the cart. So since you have velocity of the cart, if you multiply, you will find 5.36 kilowatt. This is the answer. Then when the brakes fail, for example, when the brakes fail to resist this jet of water, then the braking force will propel the cart forward. Braking force will propel the cart forward, and the acceleration will be force over m. According to Newton's second law, force divided by mass of the cart will be 1.34 meter per second square. So this is the acceleration of the cart. So I think this is the end. So please try the previous example as I mentioned before, and I propose you just you have to rush through the topics in detail and work out the worksheet exercises and also assignments. So please try out. Okay, so this is all about today's tutorial. Hopefully you liked the video and thanks for watching.